Okay, this is the SIA A21 May 2013 question on civic heat capacity. So this question is talking about a racing Formula 1 car, and when it applies the brakes if they're travelling at a speed of 88.3, all 640 kilograms of the car and the driver comes to rest. So what we're going to assume I've said here is car slowing down. So when the brakes are applied, we get friction, therefore we get heat. So in this question, we're going to assume that all the kinetic energy of the car turns into heat, and this is the energy we're going to use to find the specific heat capacity of brake pads or disc brakes. So it says here there are 4 disc brakes in a Formula 1 car, and they're made of this carbon fibre composite material. It gives us some information about each of the discs, that they have a mass of 1.5 kilograms, and that during that slowing down, their temperature rises by 970 degrees for each disc. Okay, they want us to find this specific heat capacity value of the carbon fibre composite. So to do that again, I said the kinetic energy must turn into heat. So therefore, I'm going to use the kinetic energy equation to calculate the energy supplied. So my KE is a half mv squared. Because it's the whole car slowing down, I'm going to have to use the mass 640 kilograms. So that's going to be equal to a half times 640 times my velocity squared, 83.3 squared. And when I do that, I'm going to get an energy of 2.22 times 10 to the power of 6 joules. So that is the energy it takes to slow down the whole car. Because there's 4 disc brakes, that's the energy supplied to 4 of them. Now, we know that the energy is equal to the mass times the heat capacity times by the change in temperature. It has given us the mass of 1 disc brake and the change in temperature of 1 of the brake pads. So therefore, I'm going to take my total energy supplied to all 4 of the brake pads and divide it by 4 to find the energy for 1 of the brake pads. So that's what I've said here. The energy of 4 disc brakes is 2.22 times 10 to the power of 6. To find the energy of 1, I just obviously divide by 4, and I get 5.55 times 10 to the power of 5 joules. So I'm going to first of all next rearrange this equation for specific heat capacity value, because that's what we want to find out. And C is equal to my energy divided by the mass times the change in temperature. So we now have the energy for 1 disc. So it's 5.55 times 10 to the power of 5. And I'm going to divide it by the mass of 1 of the discs, which is 1.5. Multiply that by 970. Okay, so this is obviously a bracket to work it out in your calculator. And when we do that, we should get the specific heat capacity value of the carbon fibre composite material. And when I do that, I get 381. So that's my answer. Okay. If you, however, did not remember or want to divide this by 4, to use this equation, if you're going to use that energy, you'd have to multiply this by 4 to get the mass of all 4 disc brakes, and multiply the change in temperature by 4, and it should work out the same answer.